Okay, so same issue here horizontally. Okay, the order is going to matter. So here we have a shift, the expansion, and flip last. Here we have the flip first, shift last. Okay, so when we change the order, we're going to change the functions. Okay, so we got to be careful now. Now with x's as well, when we actually write the notation, it's different than what we actually doing. So when it's really important to know when do we undo or reverse things or do things backwards. Now it's important to understand that if it says shift to the right, I'm not going to go this way to the left. It says right. I'm going to add to that number. Okay, so this expression here explaining what's happening in the transformation is exactly what I'm going to do on my table on my picture. Now what's different is when I need to put this into the notation. That's when I have to be worried, and that's when I have to do the backwards. Okay, so let's try this and make sure that we can identify when we need to do things backwards. Okay, so here's my original function. It's my square root function. I'm just going to make a table of values up here. X, Y, 0, 0, 1, 1, 4, 2, and let's do 9, 3. I don't know if I'm going to fit that on there. Okay, so we're going to, let's just do those first 3 points here. Okay, so we're going to graph those 3 points, and my original function is going to look like this. Okay, so I have my original graph here, and the transformation done in one order will give us a different graph than done in the other order. Now it says write 3. Okay, well actually let's just make sure that let's do this, and because there's no change in y, let's just make sure we just transfer the y's. Okay, so we don't have any change in y's. What we're going to transform is only the x's. So what happens to the x's here then? I'm going to go to the right, so this is a, right times 2 flip. Well, what it's telling me to do and what's going to happen to the coordinates are exactly the same thing. I don't do anything backwards here. Nothing's happening backwards. And what happens to pictures, what should happen here? It says right, it shouldn't go left, right? It's going to go to the right. The picture will go to the right. The backwards point is not here. So I'm going to do this. I'm going to write my expression. It's going to go, my new x is equal to, I'm going to go plus 3 times 2 and then flip. Okay, so I'm just going to apply that. So plus 3 times negative 2 is going to be negative 6. I'm going to take the 1 plus 3 is 4 times negative 2 is going to be negative 8. Take my 4 plus 3 times negative 2 is going to be negative 14. Ooh, that's going to be way out there. Okay, so let's graph this. I'm just going to shift my table up a bit so I can fit my graph in. So I'm going to have my graph at negative 6, 1, 2, 3, 4, 5, 6, 0. That's my vertex. Negative 8, 1. There's my point. 9, 10, 11, 12, 13, 14, and 3, somewhere about 14, and 2, somewhere about there. Okay, so this graph has been shifted to the right first, expanded horizontally next, and then it's flipped across the y-axis. Okay, so it got shifted, stretched, and then flipped to the other side. Okay, so there's my graph. That's what this order gives me. So I'm going to do the next one in a different color here. So for B, my table is going to look like this. Okay, again, I'm not going to change my y's because all my y's stayed the same. I don't have any y transformations, just x transformations. So this one here says something different. Okay, and again, there's no backwards because if it tells me to expand, I'm going to times by 2. It says to go to the right, I'm going to add. So this is nothing backwards here. Okay, so my new x is going to be, I'm going to flip first, times second, and then I'm going to add 3 last. So this expression up here in black is different than this expression in green. It's going to give me different transformations. It's going to look different. So times by negative 2 plus 3, I get plus 3. Times by negative 2 is going to give me negative 2 plus 3 is going to give me positive 1. Times by negative 2 plus 3, that's going to give me negative 5. So if I change the order, my transformation looks different. So I'm going to have my vertex here at 3, 0, my point at 1, 1, and negative 4, 5, positive 2. So that coordinate is going to be over here. So that's going to give me a very different graph than the black one. Okay, they're actually the same shape, but they're in a different spot, right? Because my shift happened in a different order. So order does matter. Okay, so that's very important. And notice that at this point, because this is describing the transformation, these are describing this transformation, my tables describe the transformation, my graphs describe the transformation, nothing was done backwards. So where is the backward step? The backward step comes when I put it into notation. Okay, so here is this is my do part. Okay, this is what I actually did. My notation is the opposite of that. So I'm going to do this over here. Well, this is kind of done down here. So for the first one, this is what my notation looks like. Okay, or so my description looks like. I went plus 3 first, then times by negative 2 after it. Okay, so this is what the algebra looks like. So this is my note. This is what I do. This is a do part of it. I undo everything, so I solve for the other x, and this now becomes my notation. So this is what I'm going to put into my function notation. Okay, so when I write my f of x, it's going to look like this. F of x, and my notation is going to be all of this in here. X over negative 2 minus 3. So having this understanding when to undo things and when to do it backwards, going from notation to the description or the description to the notation, that's the only time the backwards happen. In fact, whether I go either way, it's the same process, right? From here to here or from here to here, it's the exact same process. I just solve for the other x. So understand when the backwards happens. Okay, it doesn't happen anywhere here. It only happens between our description versus our notation. Our notation is backwards. So here, this is the same thing. This is what I actually did. Okay, I do this part here. This is my notation, right? This is to get from here to here. I do everything backwards. I subtract 3 first. I divide by negative 2. This is what I then need to put into my f of x notation. So my f of x here is going to look slightly different because it's done differently. So this is my f of x notation. And I'm going to do x minus 3 divide by 2. And there is my function notation now. And that expression comes from here when I undid that transformation. So it's really important to understand the order does matter, number one. Okay, and understand when do I apply the backwards. The backwards only happens between what I write here and what I actually do. There's one last thing I want to note, and many people are going to have been shown the factored form. And the factored form, in fact, this is factored form, and factored form always means we do the compression expansion first. Okay, so if we can always put it into factored form, it's actually kind of nice, but we're not always going to be able to do that. So we're going to have be able to know how to process this from what we do to the notation and vice versa. Okay, so you need to have some kind of process to do a multi-step transformation. If we can, later on we're going to do this, if we can, and we're going to try to force it later on in some other units, we're going to try to make sure we do everything in factored form or compression expansion first, shift last, because that's actually an easier way to keep track of vertices and critical points.